Very good morning to all. Right now what you are seeing behind me, it is a Ganit Udyan. This idea came to me few years ago, and in 2023 I put this idea in front of the management, and they were supportive enough that they approved this idea. Now, as it seems to be a normal Ganit Udyan or math park, but it is different from others, because I have seen that in many math parks, they more look like exhibits rather than the interactive part is missing here. So here what we did, we used the idea of magnets on metal boards, so that the students they themselves can come here, they can do the practicals and they can learn a lot. So for this, I have also seen that after doing it for 3 years, there is immense raise in the interest of students, and they have started taking the math in a very positive way. Also, it inclines with the national education policy, and it gives the students the freedom to do math by doing actually, not just by rote memory. So now I will show you few activities along with students, so that you can easily understand how this math park works. So first, let me take you to a small tour of this math park. Please come. We have named this math park on Ma'am Sarla Birla as Sarla Birla Ganit Udyan. Come now. As you can see down also, we have given some shapes of polygons, circles. The small tiles which are placed here, they are in form of certain mathematical shapes. This is an option where we can represent 2D as well as 3D figures or shapes. Now this was an old bicycle. We have installed it here so that the students they can learn that mathematical shapes are present in our daily life also. What is its use? I will show you in one of the activities. Please come here. Then we have installed here certain metal boards. As you can see, these are metals on which we will be using the magnetic hooks. Please come in front. Now you can see there that there are many boards like this which have been installed. So when I will be doing activity with you, I will explain you with one or two boards that how it actually works. Thank you. Now let us come with the students. And there are certain other terms which are related with the circle. We are going to learn that. Now, if I look at this wheel, in which shape is it? It is a circle only, right? So can you tell me about this point? What do we call this point as? Center of the circle, right? And what is the distance between this point to the extreme of the circle? It is known as radius. Now my question to you is, if I place one point here and place another point here, if you want, you can come in front so that you can see. And I join these 2 points. Can you tell me what this line segment is known as? Arc? Which is displayed by the rubber band here. Anyone? Okay, so this is known as chord. What do we call it as? Chord. C-H-O-R-D, chord. This divides the full circle into 2 parts. Anyone can tell me what are these 2 parts known as? Not sectors. Not semicircle. Semicircle is one of the cases. When this chord is a diameter, then it is semicircle. Now what do we call these 2 portions as? They are known as segments. So what do we call this segment? minor segment. Absolutely right. And what do we call this segment as? Major. Okay. Now I would like to call any one child here. Okay. Mukherjee, you come here. Let me place one hook here. Now I am giving you rubber band. Just join this hook with these two hooks. Okay, like this way. You also join. Okay. So now another shape has been formed here. Have you ever seen this shape? It is not triangular exactly. In some food item, have you seen this pizza slice? Pizza slice look like this, isn't it? So, can you tell me what this shape is known as? It is sector. This is known as sector. So, if I look here, this is also a sector and remaining pizza is also a sector. What do we call this sector as? Minor sector. Okay, and what about the remaining one? It is major sector. Right? Now, if these two radius are in a straight line, if these are in a straight line, then what are these two sectors equal? So what do we call these two sectors as? They are known as semicircular regions. They are known as semicircular regions. It is like your mom wears a bangle, that is a circle. But when she makes a chapati, that is a circular region. That is a circular region. So when we are only considering the boundary, it is a circle. If we are taking the area also inside, then it becomes a circular region. Now, we have to make one formula here to find the area of the sector. Okay? What do we call this angle as? This is known as central angle. What do we call it as? Central. Can you tell me the fraction of this angle with the full angle of the circle? Let us say if this angle is 60 degrees, then what will be the fraction? 60 over 360? As she said, it is 1 by 6. So it becomes 1/6 of the full circular angle. So if I want to find the area of this portion, this 1 by 6 should be multiplied with what? 1 by 6, yes, should be multiplied with what? Not 360, area of the circle. And what is the area of the circle? Pi r square. So if I multiply this 1 by 6 with the area of the circle, I will get the area of the sector. I will get the area of the sector. But if this angle is a general angle, say this angle is theta, then what will be the fraction? Theta means any variable. For example, say it is x. This angle is x. Then what will be the fraction? Yes, absolutely right. It is x over 360. So x over 360 will be multiplied with what? The area of the circle, that is pi r. So we will get area of the circle. Now if I have to find area of this arc only, sorry, length of this arc. Arc cannot have area. So what's about length of this arc? Again fraction will be same, x over 360, but it will be multiplied with what? Perimeter. So what is perimeter of a circle? 2 pi r, and what it is known as? Circumference. Okay. So if I have to find area of sector, okay. Raghuvanshi, come here. So tell me what will be area of sector? If this angle is x, then
x upon 360 into area of circle means pi r square.
Very good. Now you go, Avni, you come. If I have to find the length of the arc and x is the central angle, then
upon 360
Yes.
into the circumference.
That is 2 pi. So children, now when we will move to the class, I will give you certain questions so that we can come to know that whether this concept has been understood nicely or not. Now, okay children, I welcome you all here. Today we are going to learn something about the sum of angles in different type of polygons. Okay? So I want to ask you something. Okay, Nikhil, can you tell me what is the sum of interior angles in a triangle? 180 degrees. So he is absolutely right. The sum of angle in a triangle is 180 degrees. So first of all, we will see that different type of polygons can be divided in how many type of triangles or in how many triangles basically. So for that, I will be using some magnetic hooks here. For example, if I place one hook here in a quadrilateral and other hook here and join both of them. So, will you please help me out in holding this? So if I join both of these hooks with the help of a rubber band. So what did I get? What do we call this as? Diagonal. So in how many triangles this quadrilateral is divided? In how many triangles? Two triangles. So one diagonal, which is the only possible diagonal in a quadrilateral, it divides the quadrilateral into two triangles. How many sides a quadrilateral have? 4. And how many triangles we are getting? 2. Just remember this thing. So 180 degree sum here, 180 degree sum here. So what is the total sum of angles in a quadrilateral? 2 times 180. 2 triangles means 2 times 180. Now let us come to a pentagon. Rishikesh, come here. Can you place this so that we can divide the pentagon into? Okay. Another one, please be here only. Okay. Another one. Okay. So now if I join them, so now tell me, in how many triangles this pentagon is divided? 3. And what is the number of sides in a pentagon? 5. Number of triangles are 3. So is there any relationship which is being formed here? When number of sides were 4, how many triangles were there? When number of sides are 5, how many triangles are there? 3. So what is the relationship between number of sides and number of triangles? One number is less.
More.
In pentagon, one triangle is increased. Okay. Now let us come to hexagon. Okay. So 3 triangle means 3 into 180 degree. So what is the answer? 540 degree? Yes. Now let us come to Mrityunjay, you only come here. Come. Okay. Can you make it put the magnets here so that one we can place here? Where are the magnets? Can we have one more magnet? One can be placed here. Now let us join this alongside. So now we have, how many sides are there?
4.
Huh? How many sides are there? 6. And how many triangles are there? 1, 2, 3, 4. So now I am again asking, is there any relationship between number of sides and number of triangles formed? What is that relationship?
Number of sides increases the triangle.
Now, if number of sides are 6, how many triangles are there? 4. If number of sides are say 9, what do you think? How many triangles will be there?
7.
7 will be there. So and if the number of sides are n, what will be the number of triangles here? N minus 2, right? So if number of sides are n, the number of triangles are n minus 2. So can you make a formula for finding the total sum of interior angles with number of sides as n of a polygon? What will it be? Yes, please come here and say.
N minus
N minus 2 multiplied by?
number of sides.
N minus 2 multiplied by? Yes?
180.
180 degree, yes. So, we have generated a formula here. The formula says that if there are n sides of a polygon, then total sum of interior angles will be n minus 2 into 180. So, Arya, come here. Arya, can you explain this for octagon? Okay, stage is all yours. You do it. And please speak loudly.
Okay, so as the octagon has 8 sides, so the number of diagonals, the number of triangles that we find will be n minus 2, which is 8 minus 2, indeed 6.
Okay. So what will be the sum of interior angles there?
The sum of interior angles will be 8 minus 2, which is 6, into 180 degrees.
180 degree. Yes. Anyone? What is 6 into 180 degree? Yes. Multiply.
900.
Yes. Please come here. So what will be the total sum of interior angles in octagon? 80 degrees. 1080 degrees. Now this is decagon, right? Okay. So what will be the sum of all the angles in a decagon? How many sides are there? 10. So by which number should I multiply 180? 8 into 180. Okay, so you come here. Yes, don't worry. I am with you. So it is 8 into 180. So what will be 8 into 180?
1440.
Yes, come here. Very good. So what it will be? 1440. So what is our final observation or final conclusion here? What is the formula for finding the sum of interior angle in any polygon if number of sides are n?
N minus 2 into 180 degrees.
N minus 2 into 180 degree. Okay. So this was our today's activity. Now I will give you one worksheet based on this, and then we will solve questions.